joined today by Dr. Salvatore PAIS, aerospace engineer and inventor who's achieved notoriety for his patents and patent applications, which include piezoelectricity-induced room temperature superconductor, plasma compression fusion device, electromagnetic field generator, craft using an inertial mass reduction device, and a high-frequency gravitational wave generator. Dr. PAIS currently works for the United States Space Force, with previous experience as a scientist and aerospace engineer at the U.S. Navy's Naval Air Station at Patuxent River. Dr. PAIS has both a master's and a PhD in mechanical and aerospace engineering from Case Western Reserve University, in addition to his extensive career in the U.S. military. So I do want to put a disclaimer in. Dr. PAIS is joining us in a private capacity today. The views and opinions he shares do not necessarily represent those of the U.S. Navy, Space Force, or federal government. So, Sal, welcome. It is a pleasure and an honor to have you with me. You and I have been talking for, I think, 3 or 4 years now, right? Off and on.
Yes, sir.
So,
yes. It's my honor and privilege to be with you, Tim. You've put it this way, you have interviewed far more worthy people. I mean, Sir Martin Rees, for one, my goodness. I mean, the Astronomer Royal. How were you able to lock an interview with him? Very hard to get.
Well, Martin Rees, and I am so excited that I was able to interview him because he's going into the post-biological life. That's an area that he's really excited about, and so for me, it's just like Ray Kurzweil and Werner Vinge and the science fiction that I grew up with. Right? That's
yes.
Great
ones, yeah.
And so to be able to talk with him about that and to be able to go through those ideas was so exciting. My hope is to be able to do a book interview with him also, because he has one that's, I believe it's something like The End of Astronauts, and he really keys in on a lot of those ideas. So
it's quite a mind. Yeah. He's definitely one of the greatest of the century, if not at the millennium, the third millennium. I always forget we are in the third millennium, aren't we?
Well, and the other thing is that seems like it dovetails into this UAP phenomena because, this goes to the Tic Tac. I'm not sure where you're at on that, but I started to, I personally, I said, I don't believe in UFOs. I've heard all the stories. I haven't seen the evidence. And in 2017, my defense contacts started to gently nudge me and say, Tim, pay attention to this. There's something happening here. And so as I started to get into it, I was like, well, I don't want to believe in it, but it seems like something is happening. What's interesting, though, is like the more that I learn about it, the more I feel like this may be some kind of robotic probes. I don't know. Have you ever, I'm not sure where you're at on the UAP thing.
Artificial general intelligence is definitely very, very important. It talks to the superforce. I have this idea that the superforce leads to a super bang, which leads to super intelligence. I truly believe our cosmos, our universe, is a sentient entity. Has to do a lot with the 99.99% plasma composition. Remember the work of Anthony, I believe his last name is spelled, or rather is pronounced Peratt, but I could be wrong. Anthony Peratt.
Yeah, my good friend Pete Gerritsen, and you may know Pete because you'd know him through Paul Murad, right? He just told me about
Paul.
I
What a loss.
Paul was wonderful. Paul, I can't say he was like a second father, but
a great man. Yeah.
Pete told me about a book about plasma, interstellar plasma, and I think it was a different author, but they suggested the same thing. They said that these giant filaments of interstellar plasma could act like some form of intelligence. So,
I mean, think of our neural networks. Think of the neurons. We have 100 billion neurons, and we're talking 100 billion stars, 100 billion galaxies. I believe in Dirac's large number hypothesis. I think he was onto something, even though these days a lot of our esteemed mainstream physicists totally disregard this large number hypothesis. I believe Paul Adrien Maurice Dirac is one of the greatest minds of the last century, if not ever.
Well, could you describe that for me a little bit? Like, what is it about
the large number hypothesis has a lot to do. For example, speaking to the superforce, look at equation 1. How interesting that equation 1 speaks to the energy gradient based on not only the Planck scale, but the horizon scale, the observable universe. I put the numbers there. The mass of the observable universe on the order of 10 to the 53 kilograms, and the radius, observable radius, is on the order of 10 to the 26. And guess what? The superforce, 10 to the 44 newtons, comes out. C to the power 4, the whole thing divided by big G, Y. Again, Dirac believed that these large numbers, you could say numbers that are intuitively part of quantum mechanics as well as general relativity, they play a function in the entire universe, and somehow they're related to absolutely our quantum reality. Our quantum reality depends on them. That's why I think the superforce is so important. And a lot of people would refer to it as a fifth force. I think it's far above that. I think it's the mother of all forces. It's the one that's fundamental from which everything else comes. But we'll talk more on the superforce.
Well, the only reason I ask is a lot of these ideas that you're touching on, like for instance, Michael Talbot and the holographic universe, right? That it seems like that might kind of apply here, where he was saying there's this fundamental underlying, right, like the quantum foam or something like that, the Planck scale. And then we can't perceive that. We perceive a hologram at a larger level of that. And so that what you're describing kind of reminds me of that. But then the other part too of the entire universe having intelligence, that is something, and I'm forgetting the scientist's name, right? But the Ork-Or theory, I believe, kind of points towards that. Like Stuart Hameroff and Roger Penrose.
Indeed. The whole idea of the microtubules and the foundation of consciousness. I believe the superforce can also help us in deriving a physics of consciousness. I think the superforce is essential. I wish the mainstream physics community would engage with me on this idea and not just reject the paper sometimes within hours. Damn, within hours. I mean, it's almost as if they're dead set against it. It's as if they regard it as bogus dogma or of some sort of nonsense. It's not fringe. It is so powerful because it's the Planck force. So it speaks to quantum mechanics. It speaks to our quantum reality, and yet it does not have the reduced Planck's constant in it, which means it can act as a bridge between general relativity and quantum mechanics.
Okay, well, there you go. I think that some of the pushback, I'm positive some of the pushback that you're getting is you're working in an area that's very intersectional, right? When you get into that, it's kind of an intersection of philosophy and the philosophy of science, as well as physics, and then I think the philosophy of consciousness as well. And so that's an area that falls in between disciplines, and I think it scares a lot of mainstream scientists because they're just not sure.
But why? Why does the superforce feature in general relativity? Einstein's gravitational field equations feature that force. When you do a quick dimensional analysis, a very rudimentary scaling analysis, on the left-hand side of your GR theory equation, the Einstein field equation, you have G sub mu nu, which is basically the space-time geometry, space-time curvature, let's call it. It's on the order of what? 1 divided by the superforce times T sub mu nu, which is energy density. You can actually see 1 divided by, say, L squared, where L is a reference length. 1 divided by L squared is on the order of L divided by E, where L is your reference length, E is your reference energy, times E divided by L cubed. which is your energy density. That's the exact rudimentary dimensional analysis representation of GR theory. That's it. So it's right there. That c to the fourth divided by big G is huge. It's on the order of 10 to the 44 newtons and drives everything. Why? It's think of it as a scalar constant. So you can think of it as a, remember, GR, even though it's a nonlinear theory, in the small, in the if you linearize it based on this linear operator, on the scalar operator, this scalar operator times what? Times the space-time geometry, the local space-time geometry equals the energy density. Hence, you can say it's the superforce that is responsible for generating matter, which is energy density, within the local space-time geometrical structure. Everything in the universe, in this universe, has a structure defined by its quantum vacuum. It's powerful because Schrodinger spoke to this idea of space-time structure. He actually wrote a small pamphlet. Roger Penrose spoke of it at one time, how he regarded this pamphlet to be his introduction to GR theory. It is incredibly well written. Space-time structure, small pamphlet. We talk about maybe 50, 60 pages max. Brilliantly written. You have to read this. It's called Space-Time Structure by the great Schrodinger.
Okay.
So,
okay. Yeah. Well, and I can tell you, when you sent me that SUPERFORCE paper, I forwarded that again. You'd asked me to send that to several of the physicists, right? Because this is your latest work. So I sent that to several physicists that I know. Dr. John Brandenburg, and in fact, I think I sent this last night. Dr. John Brandenburg got really excited when he looked at it. And yeah.
Equation 1 is so important, in my opinion. And if you ever want to have an interview or podcast based only on the superforce, we can discuss equation 1 and its implication to the mass of the proton. When you put the mass of a proton, which is on the order of 10 to the minus 27 kilograms, inside equation 1, you get a radius on the order of 10 to the minus 54 meters. Guess what? That's the Schwarzschild radius.
Ah, okay.
So in other words, it's the superforce that makes the proton act as if it was a black hole. That's why the proton will never really decay. You know, they say that the decay time is very, very, very large.
Yeah.
I'll tell you right now, this thing will never decay. It acts as a black hole. And why? Because of the superforce. We have to revisit vortex dynamics. I think what you're looking at is almost like a huge force. Have you ever seen this thing on your bathtub? You know, the spiraling thing when you take a bath and then you unplug and you see the spiraling thing. Well, you can think of the outer radius as the event horizon demarcated by the what? The strong force resides on the order of 10 to the minus 15 meters. So, you know, and then this 10 to the minus 54 centimeters is the Schwarzschild radius, the quote unquote space-time singularity, but it's not really a singularity because it doesn't go to 0. It goes to 10 to the minus 54 meters. And this represents what? A black hole. So think of it as a vortex with the outside radius in its 10 to the minus 50 meters, which is basically on the order of the proton diameter, and 10 to the minus 54 being where the superforce makes it act as if it's a black hole. This thing will never come apart. The proton cannot decay, and the superforce shows that. But hopefully they will look at least to equation 1. I really thought they would think about at least review. I sent it to Classical and Quantum Gravity Journal, which is where the Alcubierre paper was also published. So it's a great journal. It's got a great impact. In fact, I really thought 3 weeks had passed. I really thought maybe they're entertaining the idea of, no, not at all.
Well, John's feedback was the reason what he'd expressed to me, and he actually, because I moderate the APAC conference. I'm not sure if you've seen APAC
Yes.
or not.
Yes,
Okay.
yes, I do.
Yeah, and
You do a great job, by the way.
oh, thank you.
You're very scientific minded. I really think of you as a physicist. That's why I speak to you in these terms, and I don't just,
Well, I
bring
don't
layman language into what I'm. Well,
I don't have
Tim,
the level of
you
knowledge.
definitely have the technical aptitude. I've heard you comment some very strong physics, or I mean, you have the knowledge. So please trust me when I say you have physics ability.
Oh, well, thank you.
Not
Thank
only
you.
that, but you've done a lot of work with ionic winds. You did a lot of practical work.
It goes back a long ways. I've had a lot of exposure to it, and again, working with like the STAFE conference and again, Paul Murad. I mean, Paul was, I would say, a formative influence for me. So,
great man.
Yeah.
I miss him big time.
Yeah,
He's the only one that looked at my paper called Conditional Possibility of Spacecraft Propulsion at Superluminal Speeds. He actually read that paper through and through, had some great comments. I was able to answer all of it. He really said this paper should have been published in a much higher impact journal. But I published it where I could get it. It's so difficult. Do you know that paper took me almost 4 years to get published?
Okay.
Conditional possibility of spacecraft propulsion at superluminal speeds. And I actually had to put in the abstract, this does not violate special relativity. Otherwise, they would not publish it.
Now, did one of the things
realities.
One of the things that Paul used to do, especially when he was in the STAFE conference, but even after he was just retired, I guess, people like yourself would send him scientific papers, and he would work with them to help rewrite and review equations and get them into journals. I'm not sure. Did he work with you on the papers at all?
No, he really loved that paper. He said that paper should have been published in a much higher impact journal at the time. But he always had positive. He was actually the only one. I remember, oh my goodness, compared to Eric W. Davis, oh my goodness, the comments I used to receive from this gentleman. And I regarded him in very high esteem. I still do. They were almost personal. At home, and oh my goodness. I'll just leave it at that.
Everyone has personalities.
Now, Dr. Putov is a much better, he's a true gentleman. Dr. Putov is la creme de la creme, as they say. So, the man published in Physical Review letters.
Yeah.
What can I say? I remember writing him an email saying that most likely if he would have not been associated with remember the remote viewing stuff and all that, they would have conferred a Nobel Prize on him for that paper alone.
That's entirely possible. And then your work goes to the SUPERFORCE. I think maybe it was Todd Desiato, someone else. When they read your paper, they'd said this is tied to Hal Puthoff's work with quantum gravity, right? Polarizable vacuum.
Dr. Puthoff, when he saw the SUPERFORCE idea, he saw the Theories of Everything podcast. He immediately said, "Wow, this is a great idea. This makes so much sense." And I haven't heard from him since, but to receive such accolades from the man, I really regard him as one of the greatest in the field.
Yeah,
especially in the field of field propulsion. Anyway.
He's done so much.
One day he will be regarded as such. I don't understand why all this derision of the UAP phenomenon. But anyway, again, let me state that I come here as a private citizen, and my ideas, my opinions are my own, and not the United States Navy's. Let me state that officially, Tim. So you know why.
Well, and
physics of UAPs is very, very important for study. Should not be dismissed out of hand like some gentleman in a certain office that I shall not name.
Okay.
Let's leave
So
it at that.
it sounds like you are leaning towards kind of the ET. Well, it could be many things, right? And so maybe ET. Other people have said time travelers. Other people have suggested dimensional travelers. So Lord only knows. But
Put it this way: extremely advanced civilization,
yeah,
possibly Earth related. Who is to say? I mean, the whole idea of these things just popping out of water, please. You see what I'm saying? You never know
yeah,
what's down there. What? We have what? More than 75% of the Earth's surface we have not really explored. We don't know what's down there, what the capabilities are, what exists. What if this is a civilization that's always been here? What if?
Dr. Kevin Newth did a paper, I think about a month and a half, 2 months ago, and he was revisiting the Drake equation and trying to update some ideas behind it. And one of the things that he had kind of hypothesized was that if ET civilizations, either biological or post-biological, if they were out there exploring, they would have found us. But his calculations suggested that they may have found us 400,000 years ago. And so what you're saying is similar to that, where regardless of where they...
Don't forget what they found in caves. How? You telling me that was myth? Some people's interpretation of some moving celestial object, an Oumuamua type celestial object? Please, come on, man. I mean, the thing looks exactly like what Bob Lazar described as the so-called sports model. And by the way, the SUPERFORCE, which is unbelievable, it actually talks to almost 3D printing out of the quantum vacuum. The SUPERFORCE 3D prints material objects out of the quantum vacuum. Look carefully what the equation is saying. And it's Einstein's equation. Just, again, a new perspective on all physics. You have to look at Einstein's gravitational field equation from a different perspective. It actually says it is the superforce that takes the local space-time geometric structure, acts upon it, and what? Generates energy density, hence matter.
Well, and that was what John Brandenburg had said. He'd said, he's like, I've looked at these equations a million times. I've never considered them from that perspective. And that's why he got excited. He said, once I look at it, he's like, I'm not seeing geometry. Now I'm seeing force. And he's like, that is really exciting. So.
And it unites something that Einstein took out, the concept of force. Planck believed in this force. And hence the Planck force. It is, the superforce is the Planck force. So he was right. This force controls absolutely everything. I truly believe this force is phenomenally important and will one day bring us to a physics of consciousness. Somehow, this superforce is related to the physics of consciousness. Okay. That's for another podcast.
Yeah.
We can talk about the PAIS effect if you want to,
Yeah, I should also ask, so with the Planck force, one of the questions that I'd heard was those levels of scale are inaccessible to current engineering, right? Like it requires so much energy to get there. So then the next...
Remember, c to the fourth. C. What is the speed of light? Remember Maxwell's equations. The genius of James Clerk Maxwell is to realize the electrical permittivity of free space and the magnetic permeability of free space relate to this value of so-called c, the speed of light and so-called free space. But again, even Dr. Puthoff said this can be altered.
Okay.
The speed of light can be altered based on these parameters. And what are they? The electrical permittivity of free space, the magnetic permeability of free space. They can be altered. So I believe the superforce can be at least nudged, if not manipulated.
That goes to metamaterials, and that is similar to what Dr. Jack Sarfati has been saying. Now, in his case, he's talking about, well, I guess it'd be the same thing. He's talking about gravitational metamaterials. I think you're alluding to metamaterials
He's
being
talking
able
about
to.
Foley condensates. I'm speaking of regular material. See, when Dr. Sarfati says that you can manipulate certain things with a 3-volt DC battery, I have issues with that because, again, remember what the PAIS effect speaks to? It speaks to breaking the Schwinger limit. And you must have gobs of energy. The generation of extremely high energy density to actually break apart the very fundamental fabric of our reality, which is the space-time fabric. That's what these particles, antiparticles pairs that come as part of Schwinger pair production, hence the Schwinger limit. When you have electric fields on the order of 10 to the, on the order of 10 to the 18 volts per meter, and you have magnetic fields on the order of 10 to the 9 Teslas. I mean, 1 Tesla is on the order of what? 10,000 Gauss?
Yeah.
That will tell you, I mean, with our best superconducting magnets now, Repco type, maybe we can get 30 to 100 Tesla, and that's really pushing the limit. That if we can somehow create 1,000 Tesla, see what the PAIS effect can speak to. Look at that paper that I published, the plasma compression fusion device.
Okay.
The paper I published in IEEE, the transaction of plasma science. Actually, it's gotten a lot of views and even citation, but from who? From Chinese teams. China is looking into it.
They do.
Our own people have totally dismissed this work. Equations 5 and 6 in that particular paper. Remember, equations 5 and 6 in that particular paper. The plasma compression fusion device published in IEEE Transaction of Plasma Science, I believe, 2019. Equations 5 and 6, very important. Anybody that studies them and understands the significance of those equations, think of the PAIS effect. What is a good rendition of the PAIS effect? And let's not talk about electrically charged solids because, it's pretty hard to generate high Coulomb material, even with Van de Graaff, with Pelletron generators. It's pushing the limits. Think plasma. The generation of extremely high energy densities produced by what? Accelerated vibration of a non-equilibrium plasma. Vibrated at a certain particular frequency, which I shall not name because that's not a good thing to bring up.
Well, that sounds like your TR3B, right? Hypothetically.
Speaks to the PAIS effect, doesn't it? And once you can produce such high energy densities, remember, your energy density times c, the speed of light in free space, is on the order of what? Electromagnetic energy flux. So your S factor, your S max can be on the order of a C times epsilon 0, the electric field strength squared.
Okay.
Right there, you can generate on the huge electromagnetic energy fluxes, speaking to energy densities on the order of 10 to the 25 joules per meter cube. That is breaking the Schwinger limit. That's actually breaking apart the very space-time fabric. That's what these particle-antiparticle production, that's what it means. You're breaking apart the very foundation of our quantum reality.
Yeah. So if I'm interpreting it correctly, then you're talking about high energy plasmas with basically waveforms applied to them, and that would be enough.
Non-equilibrium plasmas. That's a key factor.
Okay.
non-equilibrium. So we're talking about, you can call them cold plasmas. Plasmas that do not obey the Maxwell-Boltzmann distribution of the electrons within them.
Okay.
And that
Okay.
gives you an idea. How could these plasmas be created? Hint, hint, attosecond, femtosecond lasers, among other things. There are other easier way to create these. But again, the accelerated vibration of non-equilibrium plasmas can generate these incredibly high energy densities. And once you have that capability, that speaks directly to general relativity, to Einstein's field equations. You see, remember the right-handed term, T sub mu nu?
Okay.
It's really an energy divided by L cubed. That's an energy density. The higher you can get that, the more you can change the left-hand term, the space-time curvature. So the PAIS effect speaks to something the superforce already does fundamentally, because the superforce exists at every point in space and time, but it acts at the Planck scale. This is the fundamental greatness of the superforce. That's why it is the mother of all forces. It's Planckian in nature, but it does not have H bar in it. It does not have the reduced Planck constant. Hence, you can think of it as a macroscopic quantum entity, a quantum parameter that acts on macroscopic scales. What's another macroscopic phenomenon? Superconductor. How come these things that are seen to flow and, to float in the skies and so forth seem to have very low temperature? As if, right?
Yeah. No, that's an excellent point. Now, one of the things that I wondered was, maybe they are actually absorbing energy from the outside environment, right? And then, others have wondered if maybe it's some kind of active camouflage. I mean, there's so many questions about that there. Yeah, it's intriguing.
Changing the very nature. A great professor, he unfortunately passed away. His name is Kirsten Huang, Huang of MIT. Kirsten Huang. I think he's known for the Huang potential. It's in quantum field theory. His name is quite established, actually. But he had this idea. He actually wrote a book, because he couldn't publish in regular journals, again, like physical review letters. So he published this book called A Superfluid Universe. Great. Actually, I give it as a reference in my Superforce paper. I forget which number it is. It could be the last one, or close to the last one. The other one being Schrodinger's space-time structure. I think these two books are essential in understanding the potential of the superforce. Professor Huang had an incredible idea. We really live in a superfluid universe. And what's a charge? What's an electrically charged superfluid? A superconductor. How interesting. And what do photons do in a superconductor? They seem to slow down. Interesting. So you can actually vary the speed of light.
Okay. And again, this to me, this seems like it dovetails in very closely to what Jack Sarfati has been saying, is that one of the things he had said is relativity within materials.
Very small amounts of energy. That really worries me.
Yeah. There are definitely some differences, but it's exciting to see convergence.
There's some sort of exponential run on the power. Somehow this thing becomes exponential in nature.
Well, so in terms of power, one of the things that I've wondered about is, I was thinking about this last night when I was drafting questions. Okay, cold fusion, right? And the idea was, how can you get these protons close enough together to fuse? There's no way. We have to use, massive explosions and all that kind of stuff. And then this idea has emerged over the last few years of lattice fusion, right? Where you're using nature itself to squeeze them together. And then there are some other ideas there that I've heard about, like maybe we could look at shear forces where the overall force is very weak, very low power, but you get like a shear effect. You get like a wall of very, high energy, right? But it's very thin. So the overall net energy is small, but you get, shear forces that could cause these things to happen. So in terms of accessing,
that's why the equation 1 in that SUPERFORCE paper is so important, because look at it. It talks to the Planck scale, the so-called smallest of that we foresee scales, and it talks to the horizon scale, the greatest. It talks to them both, and they both come. That equation can be used for different scales. That's how you get the idea that the proton can act as a black hole. And I'm not the first. Actually looked it up and saw there's a gentleman by the name of Nassim Haramein that first brought that to the attention of the public, and they disregarded him, of course, that the proton acts as a black hole. Guess what makes it act as a black hole? The superforce. He is not very far off. I'm one day, Tim, regard this as a prophecy right here, right now. One day, our high priests of mainstream physics will look at us, the so-called fringe physicists. Not in my case, I'm an engineer by pedigree, so I'm not even worthy of being called a physicist, not even a fringe one. But anyway, in their mind, of course. And they will say, maybe we should have looked closer at what they had to say. You should, again, the idea, first of all, the divorce of philosophy and physics, the worst possible divorce of all time. Philosophy and physics must go in hand.
Yeah, I completely agree with you. And I think one of the challenges has been, it's led to this incrementalism. And the impression that I get is that in many ways it's kind of running out of steam, right? And
reductionism, materialism, divorcing everything of what could be. Again, superforce, super bang, super intelligence. And one day, if you have time, I can have a podcast with you, if you want to call me back.
I would love to do.
I can discuss.
I'll do as many more future podcasts with you as you have the time and energy for. So
I call this the triarchy of creation. Triarchy of creation. Superforce, super bang, super intelligence. The super bang speaking, there is a great analogy that comes to this. It is because of the superforce that a quantum bounce occurs. I call it an Ashtekar bounce. He's done quite a bit of work on it. Professor Abhay Ashtekar, known best for loop quantum gravity, along with Carlo Rovelli. Now, if you look at the supernova mechanism, there's something called a core bounce. Due to the due to the strong nuclear force, at a density of about 10 to the minus 14 grams per centimeter cube. Once the mechanism within the supernova, once the core starts collapsing, there's a core bounce because of the strong nuclear force at about 10 to the minus 15 meters. I say it's almost the same idea with a superforce. At this Planckian 10 to the minus 35 meters, because of this quantum bounce on an order of 10 to the 90 kilograms per meter cube, that kind of density. So we're talking about a super density. The superforce actually speaks to a super density, which has H bar in it. How interesting. But the superforce does not have H bar in it. Again, why? But anyway, so there's the analogy between the core bounce in a supernova and exactly why the superbang happens due to the superforce. And in time, the superbang creates superintelligence. Why? Because of the nature of the cosmos. Again, it's superfluid in nature. But it speaks to a plasma universe. We really have not even scratched the surface of what true physics is.
I would agree with you. Well, and again, taking things in the larger context, right? I mean, You know, what, like when people talk about UAP, for instance, you know, you could be potentially talking about civilizations that are millions of years older than us. And when you look at the majority of modern physics, I mean, quantum mechanics is just about a little bit over 100 years old now, right?
Yes.
Relativity theory, I mean, about 100 years old, right? Yeah, like 1917,
Yes,
I think,
yes.
you know, around there. So,
15 was the paper that everybody speaks to, and
yeah.
eventually he made the for example, the Einstein-Cartan equation, the whole idea of torsion fields that nobody, oh my goodness, mainstream physics has a, even if you look on Wikipedia, they say torsion field is considered pseudoscience.
Yes.
Are you
Well,
kidding?
but then,
Anyways,
and that came
yes, it
out.
speaks to the Einstein-Cartan equations. These are, oh,
Yeah,
yeah,
yeah.
don't get
Well, he was
started.
trying to, so with torsion, he was trying to connect gravity and he was trying to connect gravity and quantum mechanics, right? So he added torsion as that additional dimension. And then I'm trying to think. There was, but in terms of higher dimensional theories, there's that big
You
one.
talk about the Kaluza-Klein theory,
Yes, 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 yes.
the
Thank you,
whole
sir.
idea of the fifth dimension, introduced by Kaluza, and then Oscar Klein came in and said, you know, we can really see these, so they got to be very, you know, Planckian in nature. And
But then
eventually,
this for me, this kind of comes back to string theory, right? Because when I read Michio Kaku's book, one of the things that he had said was one of the inspirations for him to get into physics was, he said, when Albert Einstein passed away, I guess they had a camera view of his desk, and they said they had the unfinished
yes.
they had an unfinished copy of the unified field theory on it, which led him to explore that and later led him into string theory. So, you know, for me, it seems like higher dimensions are probably the way to go, even though I guess string theory is going to get
Well,
a beat up
Hilbert
right now.
space is what? An n-dimensional space is n approaches infinity. So Hilbert space is the space of everything,
Yeah.
is the space of our quantum reality. So why not? Just because we don't see them, we have no. What if some of these dimensions are even of large dimensions? What if there's a way to transfer energy through the unseen membrane between, so let's call it an interface, a sort of surface tension between dimensions? But anyway,
Well, and that reminds me of
this is true fridge physics. Anyway.
That reminds me of the Susskind-Maldacena, the ER equals
Oh,
EPR
yes,
conjecture, right?
yes,
But
yes,
now
yes.
and so one
But
of the
that's
things.
based on ADS equals CFT. And ADS, anti-de Sitter, equals conformal field theory. Remember, later on, Valinda brought to our attention that we live in a de Sitter vacuum.
Okay.
We have an expanding universe. Anti-de
Yeah.
Sitter space is not physically there, truly, even though it's such a beauty mathematical. Again, too much mathematical acrobatics trying to pass for great physics.
Yes. Yeah. Yeah.
Maybe we should take another look
Well,
at the realities. And Eric Valinda's ideas are very interesting. Very, very interesting. The whole idea that gravitational interaction may be entropic in origin may actually have to do with information theory. So,
yeah. Again, all of these are brilliant ideas. Today, we are talking about a new paper that you've written on the superforce. And
yes,
you've
sir.
written that this is a fundamental force of unification. It can also be described as the Planck force, and it's found in the field equations of Einstein's general relativity theory. And so when you mentioned John Brandenburg a moment ago, I sent this paper. You had forwarded this to me. I sent this to John as well as a few other physicists. John got really excited. And again, his feedback to me was, he said, you know, I'm familiar with these equations, obviously, but he's like, I've never thought of it like this. He's like, I've always thought of it as like a geometry. And when I think of it now as a force, this is really exciting. So that's what you're talking about with the superforce.
Yes, sir.
Can you explain the superforce a bit for us, though, in layperson's terms?
Sure. let's look at the Einstein field equations. The simplest way of describing them is space-time geometry on the left-hand side, demarcated by G sub mu nu, a tensor, is on the order of 1 divided by the Planck force, which I call the superforce. The whole thing divided by multiplied by an energy density, which is really accounted for by the T sub mu nu tensor in the Einstein field equations. That is the easiest way to understand what I'm talking about. If you see that G sub mu nu is on the order of 1 divided by the superforce times T sub mu nu, once you put the superforce, which is really the formula for the superforce is C to the power of 4, the whole thing divided by big G. So it's really the speed of light to the 4th power divided by big G. Again, big G is really an amplifier in this equation. So the whole thing becomes like on the order of 10 to the 44 newtons. Again, a humongous force. That is the Planck force, as a matter of fact. Now, what's interesting is that you do not see H bar in that, even though it is Planckian in nature, and it speaks to our quantum mechanical reality. There is no H bar in it, which means what? Maybe, possibly, this is the bridge between the world, or rather the realm of the very large, which is our macroscopic reality, linked to what? To the very smallest of our realms, which is the Planckian scale on the order of 10 to the minus 35 meters. What if the superforce unites, or rather bridges, the two realms? Maybe this is a new path to quantum gravity. The whole idea of maybe it's not about quantizing the gravitational field or geometrizing space-time. Maybe it's something about something new. Maybe it's about the superforce.
Yeah.
Maybe this is the one thing that bridges it all. And in that paper, equation 1 is very important because it actually shows the superforce can be looked at as an energy gradient at the Planckian scale as well as on the horizon scale, which is the observable universe. So once you put in energy divided by a reference length, which in our case would be 10 to the 53 kilograms, which would be the mass of the observable universe, divided by a radius on the order of 10 to the 26 meters, which is the radius of the observable universe, you get something on the order of 10 to the 44 newtons, which is what? Which is the superforce, which is the Planck force. C to the power of 4 divided by big G.
Yeah, so this is
like on the order of 10 to the minus 10, something like that.
Yeah, so this is the unification force. This is the great
This is the unification force, and as a matter of fact,
at the Planck scale. Yeah.
Yes, sir. Within that paper, if you look at chapter 3 of the paper, it's a very short paper. It's only 3 pages long. So on the second page of the paper, you can actually see that at the Planck scale, you can actually show the strong nuclear force equals the gravitational force, equals the Planck force, equals the superforce. So the superforce is both the strong nuclear force and the gravitational force at the Planck scale. So the superforce acts absolutely everywhere, at every point in space and time at the Planck scale. So at this 10 to the minus 35 meter scale. Again, the strong nuclear force acts what? On the order of 10 to the minus 15 meters, hence femtometer. Yeah.
Okay. Well, so in April of 2016, you filed a patent for a craft using an inertial mass reduction device comprised of an inner resonant cavity wall, an outer resonant cavity, and microwave emitters. In the patent, you discussed microwave resonance within the cavity, creating a polarized vacuum outside of it. And again, this touches on so many ideas that we're talking about today, right? Like Hal Puthoff, the polarizable vacuum. You're talking about the changing the speed of light within materials.
Yeah.
So is that, would you describe that as being inspired by the Superforce, or did your work on that lead to the Superforce, I guess?
That was actually inspired by Maxwell's equations, a simple scaling dimensional analysis of Maxwell's equations. I realized that you could actually write the electric field strength as sigma divided by epsilon zero, where sigma would be surface charge, the surface charge density, divided by epsilon zero being the electrical permittivity of free space. And your B field, your magnetic induction, which is usually given in Teslas, your B field would be on the order of mu sub zero times sigma, a characteristic velocity. That speed, that velocity is really can be written as what? As different frequencies of your harmonic oscillator. And as a matter of fact, there is when we had a patent examiner interview where I actually explained the derivation of this. Once you realize the electric field divided by the B field is equals to C, which is what Maxwell regarded, you can see why I'm saying that one rendition of the PAIS effect is really what is the production, the generation of extremely high energy densities produced by accelerated vibration of a non-equilibrium plasma vibrated at what? At a particular frequency that I shall not name here, but a plasma physicist will see what I'm hinting at. And as a matter of fact, equations 5 and 6 in that plasma compression fusion device paper that was published in 2019 in IEEE Transactional Plasma Science, equations 5 and 6 in that paper are essential toward driving the point. I do not understand why these patents were called disinformation, misinformation. Then again, maybe from the point of view of the adversary not getting ideas, they should remain in that realm.
There you go.
But
Yeah. Well,
this is good physics.
Yeah, it was good physics. I think the challenge was, I think what got people was you came out of nowhere with the patents, and they had military stuff stamped on them, right? You had the Navy, and so people were like, where is this coming from? What does this mean? And at the time, oh, so many rumors. They were like, who is this man? It was insane. You know, they're like, is this a black project? You know, is he building UFOs? Is the U.S. Navy, you know, secret space force, the whole nine yards? It was all out there.
All these were theoretical in nature, with the exception of we actually tried to show the production of high electromagnetic energy fluxes by using something called the high energy electromagnetic field generator. The whole idea of spinning these things like electrical charges on the order of 1 coulomb. We were trying to get 1 coulomb. Sped up to 100,000 RPM. So we're talking about 10,000 radians per second.
I saw a video.
Make a square term, and you'll see what I'm talking about.
I think I saw photos or a video of that. I think I saw a video of that, right? The HEEMG, I think.
The HEEMFG, the
now,
high
did
energy
you see,
electromagnetic field generator. Yeah.
Did you see anomalous results when you tested that?
It is true that, and I can say because the results were unclassified. So, and the Navy actually came out and said the PAIS effect could not be seen. But there were 2 very interesting anomalies that occurred, and anyone that can get their hands on the report, which because it's unclassified should be able to be out there in the public, under public scrutiny and so forth.
That your work connects to so many different areas, right? I mean, it truly does, especially, you know, I've done interviews on so many different areas, and it's amazing.
The PAIS effect can actually be used to nudge the superforce. Why? Because it talks to breaking the Schwinger limit. The whole idea of the Schwinger limit is basically the breaking apart of the very foundational nature of our quantum reality. When these antiparticle pairs are formed, what you're doing, you're tearing apart the very fabric of our so-called space-time, even though some say now that, like Nima Arkani Hamed saying that space-time is doomed and so forth. Again, space-time still goes because GR speaks to it. So on certain scales, space-time is still alive and well.
Well,
Yes.
now have you thought of doing future experiments, right? Because you had the generator, but I mean there are so many more potential future experiments. So,
I would love to be able to do certain things, but my present work has absolutely nothing to do with either the PAIS effect or the superforce. So these remain, yeah.
oh
Just
well, but maybe not within. I mean,
maybe
again, as a
one day, who knows?
yeah,
Yeah.
yeah. Well, and I was going to say as a private citizen also, right? Like just after hours, like
I would rather put it this way. I have such strong belief that this physics is correct, that I know certain effects. I would rather not.
I see what you're saying. Yeah.
It's too. This is something that has to be done in government laboratories, SCIF, and highly secure company. Yeah, just leave it there. Yeah.
Yeah. No, I
But the
absolutely.
physics, look carefully at the physics, and you'll see this is not the basis of this information. Not at all. This speaks to foundational Maxwell's equations. Actually, the heaviside version of Maxwell's equations.
Well,
Those beautiful four equations, four unknowns that Oliver Heaviside, truly, it was him and Josiah Gibbs that were responsible for bringing the mathematical nature, the quaternion nature of Maxwell's equations to the practical physicist, to the electrical engineer. Oh my goodness, the original Maxwell's equations were quite intransigent in nature. Very, so God bless Oliver Heaviside, and thank goodness that he existed. Amazing man. Again, he had problem with mainstream physicists as well. They thought of him as a crackpot, even though they used the Heaviside function. But let's not go there.
what was the saying? Science moves forward one funeral at a time, right? I mean, I think
That's
the
what Planck
mainstream.
said.
Yeah.
I think there's no need for people to die. Just people should just have the ability to, and I know I'm using a cliche by saying thinking outside the box. Just permit yourself new perspectives on all physics. Permit those perspectives, and all of a sudden, new horizons open. Just think, new perspective. This is not new physics. This is a new perspective on old physics. Why not?
I think that is one of the hallmarks of 21st century science and technology is we've already identified a lot of these fundamentals, right? In terms of physics, in terms of engineering. And I think one of the things that we're seeing is we're looking at them with fresh eyes and we're making new conclusions. That's just the feeling that I get in so many different areas,
Yes, it is. And the whole idea, for example, the nature of the plasma. People speak of liquid plasmas, of cold plasmas.
Yeah.
Everyone associates plasma with an extremely hot gas. You need the interaction, extremely high temperature. I mean, the whole idea of the sun being a ball of plasma. Well, what if there's such a thing as cold plasma, which is really a non-equilibrium plasma, where the electrons are somehow stripped off the nucleus? How? By electromechanical effects, possibly electromagnetic effects.
Okay.
These lasers can do it. Again, what's a cold plasma? It means really one that has electrons that are not in a Maxwell-Boltzmann distribution. That's what cold plasma is. You do not need to have the plasma state being extremely hot. And there are ways. Also, the idea of liquid plasmas. There are people now actually studying those. So everyone associates plasma as a fourth state of matter. Hence, they're thinking it has to be past the gas phase. So, well, what if plasma can also exist at the interface of the phases. Remember, my strong belief that it's actually the spontaneous symmetry breaking, spontaneous breaking of the phases of that actually brings in new energy, an amplification of energy effects, because of certain things that we may not understand at the present time. Because again, sometimes the mathematics is extremely difficult, extremely intransigent. But what if it's not about the mathematics? For example, I was able to find this by a simple dimensional scaling of the Heaviside version of Maxwell's equations. So what if there are other means of looking at the mathematics and understanding the intrinsic physics rather than the mathematical gymnastics that passes for great science at certain points in time? So, yeah.
Well, Sal, on that note, let me thank you so much for your time today. It has been a true honor having you with me. And let me again thank you for your career of service, which has again been truly remarkable. I want to ask if this new paper on the SUPERFORCE is a signal that you'll be doing more and more openly on your research in the future. Are we going to see you hopefully on more podcasts, doing a little bit more science in the public eye? And what should we be looking for in terms of Salvatore PAIS in the headlines?
As a private citizen, sure. But if the government wishes me not to engage, then I will not. I regard myself really as a servant of the people. And the government is the leader of the people. So if the government says that certain things should not be done, then I shall not. But if the people, as a unified voice, as a force of unification, as a super force, demand that I should be seen more and heard from, then I respect the people. They are the true master of civilization. Without the people, there's nothing. So God bless the people. And God bless you, Tim, for the service you do to us. These interviews are amazing. I've watched every one of them. So thank you for your service.
Thank you.
You're going to try, go all the way. Otherwise, don't even start. If you're going to try, go all the way. This could mean losing girlfriends, wives, relatives, jobs, and maybe your mind.
Don't know, you should take it slow. Are you searching? Is it hard to find? If you're broken,